everyone. Welcome to the live Q&A with development. My name is Marissa and I will be your moderator today. This is a unique opportunity to hear from the creators of ANSYS Mechanical. You submitted questions prior to this event and we will be answering them live. If time permits, we will also take questions live in the Q&A tab to the right of your screen. Remember to take advantage of the poll in each of the sessions. You can still view the sessions after the call until February 2021. You can access and anyone can register to view the recordings. At this time, I would like to introduce the panel. We have Al Hank, the Vice President of the Mechanical Business Unit, Sachin Verghese, Director of R&D, Tim Pollock, Distinguished Engineer, Richard Mitchell, Director of Product Management, and myself, the Senior Product Marketing Manager of ANSYS Mechanical.
Hi, everybody. Welcome to the session. I encourage you to ask any questions. You kind of have direct access to us. If you know anything about me, go ahead and watch the session earlier today. It was a nice history of ANSYS and things that's going on in our history. So thanks for being here.
Hi, everyone. My name is Sachin Verghese, and I work closely with the development teams for Mechanical. If you haven't already, take a look at the session on bringing external data into Mechanical. I heard it's supposed to be very good.
Hey, everyone, it's Tim. I find myself here one of the more senior members of this fun group of people. I'm looking forward to answering your questions. Please ask us a lot of questions. We're going to have fun answering them.
Hi, it's Richard. Yeah, also really pleased with how much interaction there's been today from all of the attendees. It's really great to see everybody saying hey from all the different countries around the world and seeing how far ANSYS reaches with its technology and how many different types of organization we're helping out with. So please keep that going. Really, really great to see.
Awesome. Thanks everyone for joining us. We're super excited to have you. All right, we're going to jump into our first session, or our first question, I should say. We're going to have fun. We're going to have conversation here. So the first question that you all wanted to know was, what was the first version of ANSYS you used? And based on the poll during the plenary session, most of you, I think the biggest majority of you, have used ANSYS Workbench version 12 back in 2008 and Mechanical version 16 back in 2015.
Good.
For me, my first version, as best I can remember, was 4.1c. That tells you a couple things. It's going way back in the lower digits, and we had very different names for our revisions. Look at that, we're 2020 R1 nowadays. And then we had letter digits and numbers and letters after the numbers. So that's as far back as I can go. And things have changed a lot, but changed a lot for the better as well.
Yeah, for me, I remember starting back at ANSYS 5.1. 5.0A had just been released, and I was working as an intern, so I came back as an intern in 1994 and working in the pre-version of ANSYS 5.1. And I remember to this day logging into a VT340, I think Tektronix terminal, which was, I thought was pretty neat. They had a mouse pointer, so I was like, well, this is cool. I don't think it had color though, but you know, go with what you got. Also, as a reminder, as Marissa mentioned, each session had a poll. This session has a poll question too, so if you go to your poll tab, you can take today's poll, which is what session did you like the best? So I'm sure each of us are rooting for our own sessions for that.
So for me, I was, as I mentioned earlier in the plenary session with Al, I was a customer of ANSYS before I joined the team here. So I started around 2000, 2001. So I started in mechanical APDL. I think it was 5.6, or maybe there was a 5.61 if I remember rightly. And I was doing analysis of all kinds of different things. But yeah, the new UI had just come out, or the button had just come out. I remember now, the button had just come out to make panels that had gone behind the main screen come back to the front again. There used to be an issue where if you're selecting things and you were picking in the graphics window, you had to kind of minimize everything and move all the different windows around to get your hands back on what you're trying to wanted to operate. Fun times.
Okay, I don't go that far back, but I actually joined as an intern. It was version 11. It was the end of version 11. I exposed some features in engineering data. And the worst thing was version 12 came around, engineering data got removed from mechanical and got put into Workbench. So it wasn't too reassuring for me. But then version 12 came out. We worked on it for 2 years, so it was great.
It worked out for you, Sachin. You're still with the company, so we
I
must
know.
be happy with your work list. So.
Awesome. All right, the next question that you all wanted to hear about is what resources are available for students to get started with ANSYS Mechanical?
Sure, I'll take that, Marissa. So like I mentioned, I started as a student. So some of the things I used to do is really just playing with the software and looking through documentation and training manuals. Now things have changed since then. So I mean, the first step I would recommend is go and download our software from the download center. And that's really free for students and anyone trying to learn the product. Also recommend the ANSYS Innovation courses, which are really free online courses for students to learn fundamentals or to deepen your understanding in certain areas. One particular course is the Getting Started with ANSYS Mechanical, which is a great way to get familiar with mechanical. And I, in my group, actually recommend this to all our interns, co-ops, or any new hires. So it's a really nice way to get your feet wet and learn mechanical. There are also other online courses, free online courses that are available as well. For example, Cornell, I think, has a very nice course on getting familiar with ANSYS Mechanical. So those are some of the resources that students can use. I know, Al, you were an intern a long time ago, and you and Tim are helping teaching a course in Carnegie Mellon as well. Do you guys have any suggestions or comments?
I'll offer an obvious one. I find many people just use Google. Google to search ANSYS, to search ANSYS commands, and you'll find ANSYS supported information out there on the internet, videos. There's some channels that have things about ANSYS and a whole bunch of other access to various information about how to get going with ANSYS. And yes, the universities are picking up more courses, as you said, Sachin. Al and I and others have helped yourself as well teach a course. So you might want to check your local university and see if you want to get your hands on it. And I want to mention one thing you said, Sachin, before. You don't have to be a student to actually download the student version. Anyone can get access to that. So it has limits in it, but it's a very capable piece of software that'll help you get going.
Yeah, speaking of the student version, again, I guess I've been nostalgic because I've been thinking about that lately. I remember, I'm pretty sure it was version 5 had a student version, and I have it on 3.5-inch floppy disks. So there was like about 10 floppy disks. And I installed it on my PC at home back then, which was probably a 386 with the coprocessor. So
what's a floppy disk?
It's the thing that looks like a save button, Marissa. Come on.
Al's nostalgic these days.
Right. The last thing too is really I encourage students to come look for careers at ANSYS, right? I mean, at least as an intern. We always, especially in the MBU, we always have a strong rotation of interns and co-ops, and we're always struggling to get talent. We draw from local universities, but from all over the country and worldwide too. So, and again, as a former intern co-op, I can speak highly of the program, and I can remember too, was really kind of fun is I would do a rotation here at ANSYS and learn about something and go back to school and kind of see it and vice versa. It was really played off quite nicely. So that was really fond memories there.
Yeah, Al, you should be the poster child for our internship program.
Maybe with a different shirt next time, though.
I would just have to add as well, another great resource that a lot of people don't know about is our LinkedIn structures page. So if you search ANSYS structures, we have a page on there that we post almost every day but the weekends, but a lot of great content on there. We're usually sharing webinars that are coming up, blogs, a lot of great things like the innovation courses, big key features on the ANSYS Learning Hub. We have our 2021 R1 release coming out at the end of January. We're going to do a huge post on that to learn the latest and greatest of ANSYS Mechanical and all the products in the ANSYS Mechanical Structures business unit. So take advantage of these great free avenues and resources.
Yeah. Hey, I'm going to go off script a little bit because that's what we could do with the live session here. I saw a question just came in that asked about what's happening in the next release, right? So, of course, we in development are always kind of out of sync because what's new for you is typically old news for us. So I saw a question that came through asking what's new in 2021 R1, which of course hasn't come out yet. It won't be out until Q1 of next year. But for us, it's already old news. So what's new in that release? Well, I'll let Sachin answer that a little bit more. But for me, some of the things are we've done some really neat things with short fiber composites, but for me personally, it's really the first incarnation of journaling in mechanical. So anyone that's ever talked to me knows how much of an advocate I am of scripting. You know, any MAPDL user knows how to script, right? I mean, anyone on the call here that's used MAPDL knows how to script. Unfortunately, we can't say the same thing is true for most mechanical users. Many mechanical users don't know how to script, and no matter how good the interface is, you're leaving something on the table if you're not scripting stuff up. So, I mean, we've been working on making scripting more usable in mechanical over many releases. You know, we have better documentation. We have a nice editor now, an autocomplete. But now, even to make it that much easier in the next release, is we'll have some level of journaling. So as you're using the interface, you'll see, you know, the scripts behind it. So I think those are the couple that, to me, I'm excited about. Sachin or Tim, anything that's coming out in the next release that you're excited about?
I mean, yeah, the scripting and debugging, that's a great one. The other one I really like is the construction line feature. I think that's a really nice feature that's going to be coming out. You can actually create line bodies right inside mechanical, create your own fluid networks. And it syncs up very well with recording as well, because every action you do gets recorded, and then you can rewrite your script to generate your own networks after that. So that's a very interesting feature.
And Sachin, is that saving users time? Like, what is the big value of that for our users?
I mean, really, one is you no longer limited to having to really create these networks outside mechanical, right? You can create it inside mechanical, and it's a huge time saving as well, because once you've done it, once you have the script ready, you can just keep replaying it with just the press of a button, rather than having to spend 15-20 minutes doing it over and over again. So I think there's a lot of time savings built into it as well.
Awesome. That's great for our users. All right.
So Pierre's session earlier on, sorry, just last point. Pierre did a session on scripting and automation in mechanical earlier on. And one of the top questions in there was, you know, how do I go about learning? Where's the best way to get tips and tricks on this? So that journaling is really going to enable that learning process. That's the time saving once you have the script is instant and really easy to kind of envisage. But the learning, the effort it takes to understand how to go and construct your scripts can be complicated. So the journaling is really going to accelerate that, which for me is the exciting bit there.
I'll add to that two things, kind of bread and butter things, and I'm not even sure if they're new in this last release. I know one isn't. The first is probes. You can snap probes to nodes now. That's a beautiful thing. You don't have to wander around and get your result at some place intra the element. You can actually get it right at the node. Second thing, and I'm going to go rogue here a little bit on this, is you can use a beta feature. If you turn beta features on, you can copy objects from the session you're in into the clipboard and paste them into another mechanical session. That's beautiful working in between sessions. I use that thing all the time.
Awesome. All right, guys, next question. Can ANSYS Mechanical connect to other platforms like SolidWorks?
Yeah, I can kick this one off. So this is really one of the fundamental pieces of the way mechanical and the Workbench environment is. It's built to be a platform which connects to other systems. So mechanical's fantastic in that I can go in there and build a structural analysis or a thermal analysis really quickly, but where you can amplify that value is hooking into other systems. So CAD systems, for example, like SolidWorks, where the geometry is created with a view to perfecting the design, making sure it fits the environment, etc. Taking that geometry straight into mechanical is really powerful. So SolidWorks is one application. Autodesk tools, Siemens tools, all of these CAD interfaces, you can take geometry straight from there into mechanical. And in a lot of these cases as well, we have something called a bidirectional link. So that means once I've set my model up, apply some constraints, some loads, run a simulation, I get an idea of what the displacements and stresses are. I can then say, okay, there seems to be too much stress in this region, or maybe I can reduce the mass a little bit. I go back into the CAD, make a change to the geometry, and then I can literally press a button and update everything all the way down the system, and then rerun the analysis to say, okay, what was the effect of that change? How was the deformations or stresses altered on the model? And that's not just for one analysis system either. So it's not just geometry to structural analysis. I could maybe have a thermal in there, a static analysis, and then a modal analysis. So all of these simulations playing one after the other, all back connected together. It's not just linked to CAD as well. I think, Sachin, you had the topic earlier on about external data. Maybe you want to say a little bit about that?
Yeah, external data is a really nice source as well. I mean, again, it's not linked to CAD, but it's actually data that can come in from an external source. So we can allow external files, just text files, or if you have trace data, such as an ODB++. So those are great ways to bring things in. And since you're talking about CAD2, one thing I do want to point out is now you can connect Autodesk Fusion 360 directly into Mechanical and transfer data as well. So that's another great way to bring data into Mechanical.
And take data out too, right? I mean, as much as we love our customers to use only Ansys products, we know they don't. So that means, if you have to output data into Nastran or Abacus, we support all those. We have a Nastran export, and we're happy to import those types of models as well. So
I will add to that, Al, you can also export geometry out of Mechanical. Maybe you don't have the original geometry file anymore. You can export it to a PMDB file, which is a geometry file that both SpaceClaim and I believe Design Modeler can read, and then you can work on that geometry after having gotten it out of Mechanical.
I see a lot of good questions coming in. One which kind of I just saw that sparked my interest was the question about undo. And I chuckle about that because all of us here in development know undo quite well. I mean, in fact, I remember, I don't know how long ago it was, MAPDL had an undo beta capability. Their undo, and Tim would remember this probably, there was an undo button, but it would literally save MAPDL database DB every single time you do an action. And then the undo would basically roll it back. So, do we have any immediate plans for undo right now? No, we don't. I think that really requires some real strong thinking. And I can tell you people like Tim have been an advocate for that, especially after using products like SpaceClaim, right? I mean, I love Control-Z, right? I mean, undo is awesome. You can't deny that. And I think we're moving closer in that, especially with a more robust scripting. But it's going to be, I'm not going to be honest, I wouldn't hold my breath for undo in Mechanical right now. The other thing,
I'm holding my breath, Al. I'm holding my breath.
Close my face.
It's on you if I expire, Al.
What can I tell you? I'm not in marketing. We gotta tell the truth on this kind of stuff. But one thing which is coming out, because we've all been burned with this, is since there is no undo, how many times have you done something like, ooh, I just invalidated my mesh. I just blew away my mesh, right? How do we prevent that? And that is coming out in the next release, which is done for us, but in January, the ability to lock a mesh, either globally or on a per part. So if you have a part, you like it, you can freeze that part, and you can safely then be sure that no matter what you do, even if you want to change the mesh someplace else globally, that part will be locked in there. So that's something we definitely have heard the request for. So while it's not as slick as an undo would be, it's a step in that direction.
And I just do want to point out that it's not like we don't have it at all. The new construction line feature has an undo built into it. So we're getting that small step.
That's cool. See, I didn't even know that. I guess I got to get in the product more often. I didn't know I could undo the construction line stuff.
I can take a breath, Sachin. Thank you.
Yeah. Hey, I see one has come up a couple times here, and it's a good question. It's a question we've talked about internally a lot. Is how do we position Ansys Workbench versus Discovery, right? I mean, I think that's something that really can be tricky, because if you think about it, we kind of have three different levels of abstraction now, right? We have MAPDL, which is FE based, right? That's an FE based centric pre and post processor and a solver. We have Mechanical, right, which is what I would call maybe a higher level of abstraction, right? It focuses more on the engineering abstraction layer. And Mechanical's mandate and job is to pre and post process as much as it can, right, for MAPDL or anybody else. Those two aren't exactly one-to-one, right? Point being is, I don't ever foresee a future where I will be able to say, let's not release MAPDL anymore. It will be around forever, as long as, and especially with Mechanical, those two are complementary. Now, in the future, more and more people won't be needing to jump to MAPDL because Mechanical will be able to do a lot of those things that you could do in there, but they're slightly different. I think the similar analogy is true with Discovery. I don't foresee a future where people won't be using, Mechanical and the ability to do everything Discovery. Discovery is really aimed to be a very designer level, quick answers, understanding at that very simple level, very closely tied to CAD as well. It's always going to be a platform for us to make vertical applications. What we'll be coming out with next year is our first vertical application on Discovery, specifically for additive. So that'll afford us that type of thing. So it's not going to be, hey, we're going to expect people to go in the future to discovery only. So we'll have all three of those out there. We'll have MAPDL for people to use. We'll certainly have mechanical and Fluent and things like that, our flagships. But we'll also have discovery for those users as well. So hopefully, and like anything else, these things will evolve, right? We'll find what customers like about discovery, especially for me. I love the instant analysis, right? I mean, that's something that is really a nice thing to basically get a quick insight on what you're doing. And then if you need deeper features, you can single click to go into mechanical or Fluent. So,
Al, I think you touched on a really good point, which kind of leads into our next question is, does ANSYS have additive manufacturing capabilities?
Good. So the answer to that, and I'll keep talking here, is yes, we do. In fact, and again, we have it in a couple different products, right? Additive is certainly for us a new area, right? It's a process simulation. Historically, ANSYS hasn't dove into process simulation, right? Welding and things like that, deep metal forming. You certainly can use our products to do that, with birth and death, but we haven't really up to this point tackled it head on, right? Even additive manufacturing, you could simulate through MAPDL if you wanted, but it'd be very difficult. But in the past couple of years, we said, no, this is important for us to tackle this head on. So we have a couple answers for users for that, of course. We have a exposure within mechanical. So it's a additive simulation. It's just part of a transient thermal tied to a static structural, or you could do inherent strain too. So there's options within that. Of course, you have MAPDL itself with the same commands. And we have a specific right now vertical additive simulation program that does, again, a very quick, not quick, but does based on the inherent strain method and things like that. We also have, and this is kind of the fun thing on it, is, and this has just got released this year, we call additive science, which it doesn't just tell you, will my part print up, but it lets you say, what's going to happen at the microstructure, right? That's the big question for additive, right? Is I can print up all these wonderful shapes, but is my part going to be qualified? What's the porosity level going to be? What are the material properties going to be at? And that's what we're starting to answer now, is diving down at that scan layer, what's happening at the microstructure? So there's a lot of stuff we're doing in that. If you or your company is interested in additive manufacturing, you certainly want to take a look at what we have. And it isn't just the simulation itself, it's the things like topological optimization, right? You can basically, since you have this freedom to print up more things, it's kind of the gloves are off to have some more organic type shapes. So lots of activity in that. As I mentioned a couple minutes ago, we're going to have a new vertical application built on the Discovery platform coming out next year, which rolls all this together into a single application. Anyone else have any comments on what we're doing with additive?
Yes, I do, and I'm glad you omitted it out. We have a very capable pre-processing capability for support structures in additive. If you just have a part that you want to print, well, invariably, you very likely need to support that part during the print process. So within SpaceClaim environment, you can currently design support structures that can then be transferred into mechanical to help you complete the process. And in the environment, and this is getting into little details, the whole environment that we have for additive includes material properties, which can be sometimes tricky to get access to. We have the Granta complementary material library and related capabilities, but we also have material properties directly for additive and available to inside mechanical, which is quite helpful.
Yeah, I just saw a fun one that came in, guys, that just popped up to think of what was the most odd or crazy analysis you've ever seen. So I'll pop in one as I'm answering. You guys can think of the answer. What you would, for me, of course, one would be the one we talked about earlier today. Was chocolate, right? I mean, I cannot believe that we've got some friends in Manlave over there in the UK that are doing analysis of chocolate and making sure the little pieces of chocolate don't break and stuff like that. So that's pretty cool. Also, another one which which blew my mind a little bit was, feminine products. They use those. They use ANSYS to help design those out as well. So it's not just gas turbines and auto and things like that. So those are a couple that kind of like you wouldn't think of ANSYS in that. But anyone else have anything else that they've come across or seen which kind of surprised them?
Yeah, an interesting example, kind of on the food theme as well. So back when I was still working in the UK, I went to a company who were they did a lot of the machinery involved in making things like breakfast cereals. So you think of your Cheerios or your Honey Nut Loops, the like toroidal shaped cereals. They design the machines that make those breakfast cereals, and the way they do it is they have a die which they extrude a cylinder through, and then a series of blades which go around and then slice off these little rings of cereal. And they were kind of interested. Okay, what's the strength of these dies and all of these other factors? But one of the things that their engineers there were interested in looking at was how long does it take to wear away the die by the cereal you're passing through it. So basically, how much steel is ending up in your breakfast cereal is one of the questions they were trying to answer. Not with ANSYS at the time, they were using it for other applications, but that was one of the challenges they were wrestling with, which is kind of like, people are actually calculating how much of the tool ends up in the food I eat. That's interesting.
It's a source of iron. That's why.
Yeah, exactly that. It really is.
I think that's my favorite part about ANSYS Mechanical. I was in sales for a while and then came over to the product side, and I was super excited to be a part of the MBU because it's more of like a generic tool. There's so many different customers. I mean, one day we're talking to Mondelez, who is modeling chocolate, and the next day it's another big customer maybe modeling gas turbines. Like it's just so vast and so wide, and it's really cool to work with all these different companies. It makes our job very exciting every single day.
A recent one that I was involved with a couple years back was a rocket company on the west coast of the United States. They wanted to simulate the weld buildup, the additive process simulation buildup, before we even had additive really available in our product. So I used a combination of APDL scripts from within Mechanical to simulate that process, and that goes to the point we were making earlier about scripting. Scripting is quite valuable and effective, and you can see the part come alive. It happens to be this rocket engine was being built up over the course of the simulation, and it took a long time to do the simulation, but they used it effectively, and now those rockets are in production of some sort, I'm sure.
Okay. Sach, anything for you that jumps out that you recall?
Nothing jumps out, but I remember going to and visiting Magic Leap with you, and we met Kinsey as well, and just seeing how they were simulating their AR devices. I thought that was pretty cool. So it was neat to see how they use Explicit to model those.
Yeah, it's neat stuff, and that's one really neat thing working at ANSYS. I'm a local person here, so I grew up right down the road, but it's been so fun for me to work and meet people from all over the world and customers too, and visit customers like Magic Leap, and we visited Disney while we were down there too, and then they're right in Disney World, so that was pretty cool. We didn't get to go in the park, but, so. Hey, I saw one that came in, kind of a follow-up on the question about scripting and mechanical. It was the question is, how do I get started? Is it the same scripting that MAPDL has? And is it IronPython or CPython? So those are all good questions. The first is it's not the same scripting that MAPDL is. In fact, MAPDL, John Swanson, watch my talk from earlier today, developed that language on his own. It's his own homegrown language, which is pretty awesome. It's very close to Fortran. Mechanical uses Python. It uses a specific version of Python called IronPython. Now, before you bash me and say, why do you do that? Because it's not super supported by Microsoft. We'll have it for some time still. But so we use IronPython, and we do have thoughts of how we can use CPython in the future. We have some thoughts on that. So you can use NumPy and SciPy. But for now, it is IronPython based. If you're trying to get started, as I mentioned, next release, you'll be able to turn on journaling. But even right now, look to the getting started. So if you go up in the mechanical, up in the upper right, there's a drop down that says getting started with mechanical scripting. And it tells you some basics as well as examples, right? The best way to learn is through examples. I think there's about 20 or 30 simple examples that kind of get you off the ground there.
Yeah. And we'll keep adding examples in there, Al, because sometimes I see some customer scripts coming through. Some amazing things that customers are doing with scripting. So it really opens up this new world and gives customers access to do whatever they want. So.
All right, Marissa, what's our next question?
I think you guys actually already covered it. Al, we know your favorite feature is obviously scripting, if no one figured that out yet. Tim's tips and tricks, he covered a lot of great of those. And then Sachin, talking about the construction line, I think that's one of your favorite features as well with the undo button. But what about, what feature is the most valuable, you would say?
I can start. I mean, that's really a tough question. It's like asking what's your favorite child. I mean, but I mean, just a small story. I mean, when we were designing the UI, that new UI last year, I mean, I remember sitting with Richard, going through all these features, and we'll be like, what does this feature do? And we'll be like, I don't know. And then we'll try it on and say, oh, this is great. Why didn't I ever know this 10 years ago? So there's so many different features. If I was to pick one, and most recently from just working with models, and this one's a little hidden away, the worksheet on the solution tab after you solve, there's a lot of great things you can do with that. So that worksheet provides options to you, what elements are used, what the results output quantity is. You can right click, perform actions, plot the elements. So really, that's one of my favorite features that's very powerful and I use a lot.
You talk about hidden features there, Sachin. I remember that sitting with you and both of us kind of scratching our heads over some of these functions, even though we've both been like more than 10 years using this piece of software. I constantly forget that the bottom bar in Mechanical, you can double click on a lot of that functionality and kind of get hold of like the area of selected elements or go to selection information for things. It's, even though you use it so often, some of these features you forget they're there and forget how useful they are from time to time. It's fascinating.
That's a nice segue into the one I want to mention. All that information, it's very valuable to use information such as length of a line, size of a face, position of a vertex. You can leverage all that with criteria-based name selections. And if you're ever doing your simulations more than once or on different geometries, that really captures a lot of the selections that you're doing to apply boundary conditions or mesh controls or even contacts and results. That's one thing I like a lot. And the other thing is the magic go-to button. Whenever I am looking at something, I want to go to a contact for that or go to a mesh control for that or go to the body for that information in the outline. And those become very valuable when you have models with tens to hundreds to maybe even thousands of bodies, large models. That go-to thing becomes very valuable.
Yeah. So, and I like scripting. It's fun. I really enjoy it, right? 'Cause it's my way at least to pretend I'm a coder sometimes. So, I mean, I definitely enjoy trying to do things with scripting. But for me, actually, my favorite features, my number one to me actually is in a modal analysis. Once it's done solving, you have the eigenvalues on the right-hand side. Single click in that table and just say create mode shapes. I mean, that to me is actually, as I think now, I'm not sure why I don't make that happen automatically, because it's like, the first thing I want to do once I finish the modal analysis is see the mode shapes. And I don't want to put them in my one, I want to see them all, unless I have 2,000, but typically I don't have that many. So anyone that's doing a mode analysis, boy, that's super handy. What else? I use the object grouping a lot, right? I mean, and I'm sure, trust me, you folks on the call, you users do things which blow me away, because the reality is most of the time we're just messing around, right? We're playing with features, we're getting pictures, we're happy. We're not trying to actually solve something real and be able to justify that it's actually matching reality. That's a much, much higher level. And I've played enough a little bit to know how much tougher it is. Anyway, when I'm doing that type of thing, I find I'm using all kinds of results, when my tree gets pretty big. So, I mean, object grouping is a great way for me to kind of partition my results out especially. So my guess is, hopefully a lot of you know that already, but if you don't, definitely look at object grouping. So, and the other one, as a developer, I always want to see the files, right? I want to see the solver files behind the scenes. So right click on solution, open solver files directory. All the time I'm using that, and you guys probably do as well. And if you care about what's happening behind the scenes on the FE level. So those are kind of my three fun ones. But scripting's good too, Marissa.
Anytime I talk to Al and I'm like, okay, what should I be talking about? He always says, no matter what, scripting.
It's got to be important, though. I want everyone to understand that, right? And Tim on the call, who I sit very close to, I'm always messing with him because he's the prototypical user, right? He knows MAPDL back and forth, right? He's using command snippets all the time. He can write macros, all those types of things. And to toot his horn, there's probably nobody in the world that knows Mechanical better than him. He knows it better than anybody in the world. Yet I can't get the man to script yet. So I'll know that I'm successful and happy when I come by and I see Tim actually scripting away in Mechanical someday. And I hope that'll be the same in the future for everybody on the call that uses Mechanical. That'll be opening up the scripting in the future.
One thing I want to add is also the search feature, right? That came with the new UI. Because when we moved to the new UI, to get all these messages saying you've lost this feature, it's gone somewhere else. But you can actually just search for it. It's made me lazy in one way, but actually preferences and things, I can just search for it and go directly to it. So that saves a lot of time as well.
Awesome.
What do we got next, Marissa?
We have, how do I take advantage of high performance computing, also known as HPC?
I'll take the first crack at that, Marissa. There's a couple ways. First, you need to know about that little box in the ribbon where you can set the number of cores. You should be using nearly all of those cores on the platform that you're working on. That's one obvious way. Most computers, the PCs that you come out with have 12, 16 cores, so you should use 10 or 14 of those right off the bat, and that'll make the solver run quicker and even, I think, speed up some things like post-processing.
So critically, not all of those cores then, Tim? Yeah,
that's right. Not all of those cores, because you'll kind of bog down your platform or your environment, and you want to be able to do Outlook while your simulation is going on. It won't bring it to its knees, but you don't want to use them all. The next thing is find someone in your workplace or in your environment that has access to a cluster. Many companies do these days. Most of our customers, particularly the large one, have cluster computers, Linux boxes that you can either use RSM, the Remote Solve Manager, to send solutions from Mechanical to once that is set up. Or if that's not available, you can just generate the input file. I do this all the time. Copy that input file over to the cluster and learn how to work there at the command line in a Linux window, submit those jobs and use hundreds of cores there. I typically use 128, 320, 500 or more cores sometimes if I have large millions of node models and I want to get quick turnaround. Speed is very important. So that's another thing. And also, you could consider exploring Ansys Cloud. That is our own internal Ansys effort to better integrate Ansys Mechanical and all of the Ansys portfolio with the HPC environment. It's ironic in many ways. When I first started with the company, we didn't solve anything on our local computers. It was all off on some mainframe or mini computer off in the computer server room. We would go down there and send I had a stack of cards, and we'd take the cards down and run them into the machine and get it output that way. But that we're kind of going back to that in many ways, where you're taking your jobs, you can create the input for them, submit them off to some cluster somewhere, and there's a whole host of public clusters. It's becoming a business, and it is a business where you can submit jobs for running and then get your access back. And the Ansys Cloud Initiative is going to take that even further, where you can actually save your data in the cloud and perform your simulations completely in the cloud, including pre and post processing. So keep your eyes open for that. That's going to be developing more in the future.
It's funny, as I was doing some research, I'd learned that the earliest versions of Ansys, you paid per CP hour, right? I mean, it wasn't. So maybe for those that have been around can remember that, and we're kind of going back to that with the cloud, like Tim said, is you'd be paying per CP time. So I see Irene just chatted something in there. When you're solving, Tim, is it on a single node or multiple nodes when you're doing those cores? Do you remember how you do that?
Usually it's multiple nodes because each node has a limited number of cores to it. So you can do it across any number of nodes.
Yeah, and that's the nice thing about, by the way, Ansys Cloud, not to push on that one too hard, but you basically just say, okay, I want to solve, how many cores, 128. And what we've done too is we understand too that you don't want to fully subscribe your nodes either. So what we really do is we half subscribe them, because Ansys, the Ansys solver typically wants the memory bandwidth more than CPU. It's not like CFD. So, a good rule of thumb, and some of our customers have done this too, is they'll only use half the nodes on a machine. So that way they get the memory bandwidth, but not oversubscribing. So I think that's something, it's definitely a learning experience. Anyone that's doing HPC, run some benchmarks, see what works. It's important, memory is important, disk speed is important. The other thing about HPC, we shouldn't ignore pre and post processing. And actually, again, one of my favorite features that Mechanical had is parallel meshing. Boy, I forget what release it was. It might have been version 11 or 12. And you take it for granted now. You don't even realize it. But I mean, Mechanical parallel part meshes now. So, and it's just, and before that, it was a single part. And I can remember it was so awesome. Richard talked about earlier some of these big assemblies, 200-part assemblies, and you would just wait forever to mesh. But now on, my 20-core PC here, it just blows through meshing, parallel parts. So that's something that happens automatically, no charge, by the way, everybody. You're not paying for that. So and we do similar things with post-processing and mapping too. So we definitely have more ways to go. It's a challenge for us to understand that clock speed's not increasing. It's the transistors are coming from more cores, and we have to find a way to use that type of parallelism.
Yeah,
Awesome.
so we touched on that parallelization before, Al, in the plenary session, and one of the things the developers are doing is really kind of working on running models on 10,000 plus cores, which for most users is unrealistic. But what it does is it forces everybody to think about how every little piece of code can be as efficient as possible. So even when you say, okay, we can run on 10,000 cores, that does have an effect on people running on 20, 40, 50, however many cores. So it all trickles down. So it's good to see, but it's definitely a challenge.
All right, Marissa, what's next on our queue there?
There's a lot of comments about LS-DYNA. So can you maybe shed some light about what the plan is for LS-DYNA and integration with ANSYS Mechanical?
Yeah, that's a great question. And I definitely see a lot of chatter on that, and we're a little bit more than a year into welcoming LSTC into the ANSYS family, and they're of course in the MBU, and it's been really great. I've had the pleasure and the honor of getting to know the team out there, and knowing John Hallquist quite well now, and it's really been great to have them on. And that certainly was number one question, right, a year ago is, whoa, what's ANSYS going to do with this? Are they going to disrupt this thing that we have going, because Dyna and LSTC is known for their great customer awareness, and I think over the year, we've kind of shown what our plans are, right, that we will continue to drive the solver, and I've gotten a much better appreciation for the Dyna solver. It isn't just about crash, right? It isn't just about metal forming or something like that, or explicit drop test. I almost weekly am seeing and learning what new things it can do, and the physics, the multiphysics is amazing. Now, what are our plans for that, right? Let's talk about first and foremost, the number one priority in the MBU, in our group, is to really accelerate the time to expose the functionality in Dyna within Mechanical. How many years are we into it, Tim? Well, we're about 15 years in exposing the MAPDL solver into Mechanical. We're not going to take that long for Dyna. Of course, we've had Dyna exposure in Mechanical even before the acquisition, but now it's like we see that that it's all part of the same family now, same company. It's a priority for us. So we are working furiously. Satya's team is working furiously. The best features, the most important features of Dyna Solver exposed in Mechanical, things like SPH are showing up. And if you look at 2021 R1, we didn't say it, but you'll see there's a whole host of new capabilities in Dyna being exposed in Mechanical, and that's going to continue at a rapid pace for years to come. So our expectation is we are super happy now. We have an awesome implicit solver with MAPDL. We have an awesome explicit solver with Dyna. By the way, Dyna has a good implicit solver too. So point is we're taking all of those, exposing them into Mechanical, and just going to be rocking it. So that's our plans for that. And the question came up about what about Autodyne? And at first I was concerned about the Autodyne product and team, right? Because all of a sudden this giant comes into the company, but it's been nothing but goodness so far. The Autodyne team immediately said, hey, let's start talking. How can we work together? And they've done some really interesting development so far to start to even exposing Autodyne functionality in through Dyna. So we see that as a possibility in the future to really expose it through there and really hooking up Dyna directly to Mechanical via Autodyne in the background. So it's certainly evolving, but we certainly are happy right now in getting the developers connected up and talking together of how they can basically come together and work together as a single explicit group there on that. So I think, did I miss anything about that? Oh, I saw one thing about too, Dyna on ANSYS Cloud. The answer to that is yes, and I've done it myself. You can solve on LS-DYNA on ANSYS Cloud directly from Mechanical even. Works the same way. So for those that haven't, it's a pretty easy process. You're in Mechanical, you download a small apt extension, which will connect you to the ANSYS Cloud, and you just basically put in your login information for the ANSYS Cloud, say what size node you want to solve to, small, medium, or large, and you launch your job. And that works the same whether it's MAPDL or Dyna. So it's a pretty neat thing out there to try out. It's definitely, I definitely see that we have to be, open to that. That the cloud's going to become more and more prevalent, and certainly there's concerns, security, privacy, but I think you can see the shift, like Tim talked about, moving back that, because you and your companies don't want to be in the business of worrying about, IT and deploying hardware, right? You want to be doing simulations. Same for us. So I predict in the future we're going to see a continued migration to cloud for FE. Just like all of us today, how many people are using cloud-based email? I know all of us are, right? So if we trust our safest, most secure, email exchanges through cloud, in the future I'll see the same thing for our FE data as well. Anything else, guys, to talk about with regards to LS-DYNA?
No, really. I mean, you touched on that. I mean, it's such a powerful solver, and the solver does so many things. Exposure and Workbench, we just need to be selective and prudent what we're going to expose every release. And we've accelerated that heavily, actually. 2020 R1, so many features. If I have to pick some goals, I mean, we want to keep improving usability, right? Make it very easy for the users, just like the MAPDL solver. We want to focus on areas like drop test simulation, maybe even turbo machinery like fan blade out and other areas. And the other thing is, I mean, to let our power users have complete access to. So that's going to be something we're looking at, being able to access keywords and things like that. So those are some of our goals for 2021.
I would say too, just a little plug-in to make sure you're keeping up to date with the latest releases. Our next one is at the end of January. We'll have blog posts. We have a big webinar coming out at the end of February with Richard and Sachin talking about the latest features. So always be looking on our website. Follow us on Ansys Structures LinkedIn. We'll have a great What's New video coming out with the technical team. And hopefully you guys join us then to learn about the greatest, because again, every single release we're coming out with greater capabilities and more integration.
Yeah, just on that point, actually, we missed talking about one of the features of Mechanical. So when you install a new release, we added the What's New page. I think we started doing that 18.2, somewhere around that. So on the new interface, if you go to the furthest left tab, the Home tab, you can go back and see what's new, and it'll lay out a lot of the new features that are in Mechanical, and also give you a link to previous releases as well. So maybe if you went from one release, skipped a couple and went to a newer one, you could kind of review all the cumulative changes that have been made. So that's a great way of kind of seeing what's also new in the software as well. Sometimes we forget that's there.
Yeah, that's right. For years I told people, if you don't read the documentation, at least look at the What's New page and the release notes so you can keep up on what's happening release to release. So I see a question in here, which I'm going to put Sachin on the hot seat for this one, because he's in charge of development for Mechanical. So at what point do you decide to incorporate a new feature which was previously only done by scripting?
So, I mean, so really, I mean, it comes down to usage, right? How many people are using it? And really, that's been a great way for us to actually validate some of these features before they go in. Because just having it via script and seeing how it works or what the feedback is really makes it very easy for us to put it into the product. Now, having said that, there are a lot of these, especially as scripting has evolved and with recording coming into play as well, we're going to see a lot of this. So selecting this will be, it's going to be a tough choice. But then it also points out that, I mean, some of these features, maybe scripting is the way we go with some of these features, because actually some features in Mechanical are completely script based. For example, some of this convert to and select logic, we've written it the same way a user would script it into Mechanical. So really sometimes even under the hood, we're using that same scripting to expose features as well.
Yeah, well, I would say too, another facet of this question is people that are using command snippets, right? And accessing MAPDL functionality through Mechanical, and may say, hey, that's only a one-line, MAPDL input command. Why don't you put it in Mechanical? And that's a question I've definitely have seen and lived through many years. And the answer for that is, it is one line, right? But what you have to appreciate is what Mechanical bears the brunt of responsibility is making sure that command is compatible with all the other permutations that Mechanical can do, right? Whereas for MAPDL, the onus is on the user, right? If he uses some cyclic command with some load which isn't compatible, tough noogies for him, right? Or some physics. But mechanical really, and most of the time we spend, and again, I used to code a lot too. Most time we spend was trying to make sure that feature A fits with feature B, right? That they're compatible and they give the right answer and they make sense. So I mean that's where, and so it is definitely a wrestling match, sometimes. And then so we say, well, do we leave it as command snippets? Do we use an act extension? And then finally, like Sachin mentioned, it's users drive us, and we see, okay, let's formally support it. Let's take the time for it. The other thing too, which really helps us, is we have the APIP program. We opt into that. It's the process improvement program. That, for those that aren't aware of that, is something that basically you're filling out a small survey, very anonymous, that says, what are you doing? How big is your model? What features are you using? And we're able to use that both at the solver level and mechanicals level to get a sense of what's important to users. What do we have to make sure we're doing right? What's trending up in popularity? So that also gives us that insight of, really what do we have to make sure we pay attention to.
Yeah, just quickly on that as well. We've had customers ask us, can you tell us what information we're sending you? We genuinely can't. We get information about how many parts are in a model, what load objects are in there, maybe how much RAM is in there, what type of CPUs, but we can't tell any part names. We can't tell which organization you're a member of. So the data is really anonymous, to the point where we can't tell if a customer is sending us information or not. So we just ask that when you install the software, if you are able, please do check that box that you'll be willing to send us that information. It really helps with the software. And to Sachin's point earlier on, it's a tough job deciding which areas which scripting items to turn into released features. I think every single person at ANSYS would love to be able to say yes to every customer request that comes through. But just like every other organization in the world, we have a limited number of people, a limited number of hours in the day. So we've got to pick carefully, and hopefully we get it right more than we get it wrong, is all I'll say.
Yeah. Another thing with respect to APIP too, is it helps us make the software better, because, there's certain features we talked about, that we love, and that really every single user should be using, right? I mean, things like grouping or some of the things that Tim mentioned and Sachin mentioned, but we find through the APIP program that, what we thought should be 80 or 100% usage is like 8%. So we found, that we weren't getting the message out. In fact, that actually what drove the new UI to an extent, right? I mean, last year we released a new ribbon-based UI, right? And we had the searching capabilities. A large part of that was because we felt people were having trouble finding the features they wanted. And things which were important were getting lost. And the old toolbars were just getting unwieldy. And I can remember screenshots of toolbars that took half the window up for the user, right?
You can get 7 lines of buttons in there if you try hard.
Exactly. So, I mean, it was that type of things that said, okay, listen, we have to do a better job to have the software self-educate people. And again, just thinking, I mean, you hear a lot about AI ML stuff, right? And where's simulation industry's place in that? I mean, it would be cool someday before I retire to have that kind of built into mechanical, that as I use the product, it kind of guesses, infers what I want to do. Just like, I mean, how often are you amazed, you don't even appreciate it, that Google knows what you want? I mean, it's like I type in 3 or 4 letters and it knows what I want. I don't think secondhand of it, but it really is quite amazing. So it's kind of maybe a little bit futuristic, but it'll be really neat, hopefully before I leave ANSYS, and when I retire from ANSYS, that we would have something like in there that kind of lets me think what I want to do. All right, back to Marissa for our next question.
Yeah, I think we have time for about 2 more questions. Are there plans to make it easier for us to take back deformed geometries from analysis back to CAD?
Marissa, not only are there plans, work has been taking place, and in the next release come January, there will be an ability to do this right in our next version of the software. And that'll manifest itself in a couple ways. You can use the project schematic to take a result cell from one simulation and drag it into a geometry cell of another geometry system to actually perform what's in space claim, to either highly automatically redefine that geometry. It'll send over the facets of the deformed mesh and the geometry, and from that, with a quick automated button, it usually works, not always, it'll create a new geometry from it with the same topology as the former one. If that automation doesn't work, there's other tools in there that let you patch up that faceted geometry and then continue to construct it. And after that, you can go on and do the next simulation. So that's, to your question, the ability to take deformed geometry back. But we also have the ability to take topologically optimized geometry, which can be very radically different from the original geometry. In those cases, many times it's a block and you've optimized it, topologically optimize it to a generic shape. Those can be also fitted into real geometry by some of the features in SpaceClaim. So please check that out. As optimization becomes more prevalent, the need to produce real geometry becomes greater.
Yeah. And for those, hopefully many here on the call know about SpaceClaim and use it. And it doesn't cost, it comes with the Mechanical Enterprise license, right, Richard? So it's not like we're had to pay extra. So I mean, it's an extra functionality at your disposal, you know. And so certainly you're probably using some major CAD system like Creo or something like that. We're not saying to get rid of those, but SpaceClaim is quite capable and it's really developed for to help analysts. So it's I've certainly, and I haven't used Design Modeler, and if those who know that is, that was our only prep and geometry prep program we had a couple years ago, but I haven't used it for years. I haven't had to look back. So, and SpaceClaim is a really nice direct modeling, and it's got some nice functionality in it too. It's got a little bit of a learning curve, but that's true for anything. Anything that's worthwhile takes some effort, but
it also has undo.
It has undo.
Hey, so just before we go to the last question, I think we're about coming up to that. I'm just looking at the poll in the chat here. And Tim, your session on tips and tricks is leading the way here, so you're clear ahead of everybody else. So well done on that. If you haven't taken a look at the poll, it's next to the chat. There's 3 chat questions and polls button just in this session. So if you haven't done that, then we'd love to hear what you think. But Tim's session is leading the way here in a minute.
Yay, Tim! Way to go.
Tim's the winner. We'll take him out for dinner.
Okay.
I need to go add some votes onto my section. Click away.
Funny story, right when I started in this position, I asked people to do a 12 days of mechanical, similar to like the 12 days of Christmas. And Tim responded and probably was like, who is this girl asking me to record myself? Yes. And we have come such a long way, Tim. Look at you. You're doing a live session for live Q&A, and your session is the best performing. So way to go.
Thank you.
All right, last question to close this day out. It was my personal favorite question to come in. And it is, does ANSYS make the world a better place? And the reason why I love this question so much is because it is my favorite reason why I work at ANSYS, because the answer is yes. Of course, we're making the world a better place. Maybe not in the way that you think. When I first came to ANSYS, I knew nothing about software. I'm not a mechanical engineer by trade, but I didn't realize that I would feel like I was making a difference every day at my job. And what our customers are doing is absolutely so amazing. I mean, you saw today how we're using ANSYS Mechanical to simulate chocolate, but on the other spectrum as well, which again is making the world a better place, if you ask me. But really, our customers are using ANSYS Mechanical to innovate, right? You see the world around us, 5G, electrification, everything. I mean, people are using our tools to create these smaller PCBs to fit inside smaller devices. Our products are enabling engineers to think differently, to innovate. I mean, think about medical devices, right? There might be using ANSYS Mechanical to design a medical device that is saving people's lives all throughout the world. Perfect example is LS-DYNA as well. Crash simulation, like Al mentioned, it does crash simulation so well, but it does more things beyond that. But it's creating safer cars for people. Government regulations and strong customer demand for higher mileage vehicles, making people every opportunity to design fuel efficient cars and automobiles. I think one of my favorite examples is when I worked in sales in Boston. I live in Connecticut now, but I was working with a lot of healthcare companies that were creating pharmaceuticals in big bioreactors and mixing tanks using our software. It's just absolutely amazing. It amazes me every single day that maybe a geometry is simple. You look into ANSYS Mechanical and you might be, simulating a little part, but who knows where that part is going into. I think something we can all relate to is COVID-19. Our software can actually use to design UV light treatment systems to deactivate the virus, or simulate how droplets travel from person to person, or how a mask fits on your face, and how it's really affecting the spread of the virus. I'm going to throw in a link into this chat window, and there's a whole bunch of other really great examples of how we're making a difference with COVID-19 and really affecting the whole globe that is experiencing this pandemic of COVID-19. So with that, we're right at the top of the hour. Any other comments from our panel?
Well, I'm always grateful to our customers. We get to work with companies doing just phenomenal stuff all around the world every day. And just when you think you've seen everything you can do with a block of steel or a spinning thing of various descriptions, someone comes up with something that just blows your mind. Additive manufacturing, case in point. You think you kind of understand the process, and somebody goes, but what about this phenomenon? It's like, I didn't even think about that. So it's just a hugely interesting place to work. Fantastic customers. I've got to say, I'm very attached to my colleagues as well. It's a great place to work.
Yep, likewise, Richard. I look forward to doing this next year, right?
Yeah, next year, like not in January, hopefully another year so we can prepare.
We'll get undo by then. Don't worry, Tim.
Oh, good.
Yeah, this undo button better be there by the time next year comes around.
Oh, now it's in stone. Now it's in stone.
We're not recording this, so it doesn't matter.
Yeah.
I want to say hats off to our customers too. I know one is in this event. He was logging on from Australia, which is an ungodly hour at that time of day here in this live session. So kudos to all of our customers. It's been a great experience working with them, and I'm sure we all have that experience here as well.
Yep. So a few housekeeping rules just before we close it out. As a reminder, the question and answer, the chat windows are now closed at 2 p.m. Eastern Standard Time. But we'd love to hear from you. So there will be a survey that's going out. So we'd love to hear on how we can improve for next year. The sessions are going to be available to be viewed until February 28th, 2021. So you have a few more months. If you want to pass this on to colleagues, just make sure they register, and then they can view all of these sessions at a later date. Anything else, everyone? I mean, again, huge thank you to this team for making this such a great event. I'm so thankful to be a part of this ANSYS Mechanical team, and thank you all for joining us today.
Okay, thank you, Marissa.
Bye, everyone.
Thanks, everyone. Have a great day. Bye.
Bye.